Alright, so for today's college algebra video, I have a completely unavoidable topic for our class that will come up many times throughout the semester, and that's the idea of a function. And by now, you probably know what we mean by a function, but the domain and the range of a function. Okay? Now, I said you ought to know, or you probably do know what a function is. But why not? We're here, let's talk about it. What's it mean? This is a slide from some other video that I did. What's it mean if we say y is a function of x? It just means that x and y are paired together so that if you plug in one x, you get out exactly one y. Okay? So a function just pairs the x's and y's. Whatever you think x and y are supposed to be, it just pairs them together. Now, so let that thought sink in, or just remind yourself about it. Here's what domain and range means. The domain of a function are the allowed or possible x's for that function. And sometimes people say the domain just means the x. And I don't know, if that works for you, go for it. I think it's a little too simplistic to say it like that, but if it works, then you can just think the domain is the x, and the range of a function are the allowed or possible y's for the function. And you see how that comes about? I mean, if a function just pairs two things together, x and y, then we might want to know what the x's and the y's can be. And that's what the domain and range are. Okay, now let's take an example where we're given the situation and we try to find the domain and range. Okay, suppose the function's given as a graph. Can a function be given as a graph? I don't see why not. This is probably, who cares? I actually don't care if this is too repetitive or not. But here I'm showing you this again. If a function just pairs an x with a y, then, you can have a function given as a graph. The fact that I made this point right here really bold, what's that mean? This is the x-axis, this is the y-axis. See, 1, 2, 3, 4, 5. 4, so that's 5 for x and 4 for y. So does it do the job of pairing an x with a y? Well, yeah, then that graph does that, and that's what a function is. Can you have a function given by an equation? Sure, plug x in, get y back out. It's all the same thing. It doesn't matter if you have a graph, if you have an equation, if somebody just tells you, it's just a pairing of the x's and the y's, all right? So let's answer the question about, for this function, the way that it is, what's the domain? Okay, we'll write our answer. And then what's the range? Okay? Well, if the domain is just all the allowed or possible x's and the whole thing, then, let's try to look at it like this. Can x be 5? Yeah, like right there at that point, we got 5 for x. Do you think x could be 4? Yeah, because there's like this point. And can it be 3? And can it be 2? And could x be 1? Yeah, look, what's this point right here? 1 for x, -3 for y. So, there's all these points on here. I only made 2 of them bold, but they're all there. It looks like, as far as that goes, what the x can be is anything from 1 over to 5. All right? Can x be 6? No, 6 is right there, and there's no point on this graph that has 6 for x, okay? All right, so I might say, let's say here's the verbal domain. The domain of this function is that x can be anything from 1 to 5, okay? We could write like this, and that would get the point across. But, if we use my math lab, or we use a book and we look up the answer in the back of the book, then it's, the way here's the way it is in math. There might be lots of different ways to write the answer down. I can't change that. That's just the way it is. You're going to have to accept that. The way that we write down the domain in our class is with interval notation. So we'll say like 1, comma 5. And we put brackets around the 1 and the 5 to mean that we include the fact that x could be 1 and it can be 5. And that just says anything in between 1 and 5. Okay? So that's how we'll actually write the answer. Okay? All right. The range now is like, if you can understand one, you can understand the other. If you can understand the domain, have total confidence you can understand the range. But look at it like, can y be, like, what's the smallest, lowest value that y can be? That point right there is at the bottom. Y is -3, as I indicated. Looks like it could be -2 right here. -1, 0, 1. I mean, you get the idea. Like, there's lots of different numbers that the y can be, but it looks like it's like everything from -3 for y up to whatever this point is, 4. Okay, so we could do this. We could say the range, -3 at the minimum up to 4. Y can be anything from -3 to 4 if you take all the points that are on that graph. Okay, all right. That is the truth, and that would be correct. But, you know, I told you that we write the answer a certain way, so I want to write that interval notation down in the way that gets the point across. So that says y can be -3, y can be 4, and it can be anything in between. All right? And those are all of the possibilities for x and y if I'm given that particular graph. Okay? All right. Now, you know, some people, you can see one problem and you get it. That's all you need. Most of us need to see more than one problem. So let's say that I give you a different looking graph, and I say, well, this is a function, all right, and it's got points on it, so on and so forth. And we'll look at just like that one, and we'll give the domain, and we'll give the range. Okay. All right. Now, first of all, that's open. Okay, meaning that I'm not really including it on the graph. And you might say, if it's not there, why do you draw the open circle? Well, because if I don't draw the open circle, it's just too hard to tell, like, where does this line of points actually stop? Okay, what I'm saying, it goes right up to there, and it doesn't include that. Okay, now where does it look like that spot is, that open point that's not actually included? Just every point right up to that one is included, but not that one. So that point is 3 for x and 2 for y. 1, 2, 3, 1, 2. Okay, and that point is open, and it's not there. But it's point right, whatever microscopic point next to it is on the graph, but not that point itself. So all right, same deal. Let's look at it like the other one up there. It looks like x can be, well, x can't be 3. But it could be 3.1, 3.2, 4, 5, and so on. So I want to say something like x can be anything bigger than 3, but it can't be 3. So we could say like this. Here's what the possibilities for the x are. X is greater than 3. Did I put greater than or equal to? No, I just put greater than. This 3 is not included. Okay, all right, so that's, will tell you the truth. You could say this was the domain, just the fact that x has to be bigger than 3, okay? But the way that we do that with this here with the brackets and so on, that's called interval notation, is we put a parentheses to say that I'm not including the 3. If I were to put the bracket, I would be including the adjacent number, but here the parentheses says I'm not including the 3 because 3 is actually not on that graph, but I need to have anything bigger. So from 3 to, well, I mean, doesn't this just goes forever to the right? Look at that arrow. And where's forever at? Infinity. Okay, so we put parentheses around the infinity too. All right, so there's our domain. And what about the range? What can the y be? Well, at that point that's at the very bottom, y could be 2 if that point was included, but that point's open, so it's like y could be 2.1 or 2.2 or anything more than that. All right, so we could say for the range y is greater than 2. Anything bigger than 2. 2's no good. 2 for y is actually left off, but anything bigger than that is okay and is on there. So we got to say for the range 2 to infinity. It's like saying everything from 2 to forever, as the graph will rise forever, just like indicated pattern. But I'm not including the 2. I'm putting the parentheses to not include the 2. Okay. All right. So those two problems, I wanted you to see that they are similar in some ways, different in others, but same concept with both of them. Now, let's say that a function was given as an equation. How is that different? It still just pairs x's and y's together, but I want you to think about how would you figure out what the x's that are possible are supposed to be, okay? Now, so for these, I only want to give the domain, all right? And in our book and on my math lab, and yeah, it's just going to ask you for the domain. I'm inclined to say for this one, wouldn't every x work? I mean, is there any number that you could plug into that formula that wouldn't work? I mean, imagine that you were just doing the calculations. 2 times a number plus 3. And you got your calculator. 2 times, pick any number you want, and then say plus 3, and then press enter. You're always going to get an answer. Okay? Always. Like, nothing can go wrong. I mean, if the domain is just the allowed or possible x's, there's everything is possible. Everything can be plugged into that function. Okay? So I'll just tell you about that one. That it's everything. Or you could say all x's if you want to. Does that get the point across? I think it gets the point across, but what's the right way that we're supposed to give our answer? To say negative infinity to infinity. Okay? That would include literally everything from forever to the negative numbers over to forever to the positive numbers and everything in between. Okay? All right, now you might look at that one and say, well, that's way too open-ended. I mean, it's like you're just supposed to look at it and know that it's everything. And my answer would be, well, yeah, I mean, just nothing can go wrong there. So that's what I can tell you. But how about for others that we might see? Here's our hint. Okay? If the domain is just the allowed or possible x's, then what can go wrong if you're doing math and not actually lead to an answer? So, like, are there numbers you could plug in these functions that would lead to problems and we wouldn't get an answer or something like that? So let's say this hint for the domain, we basically just need to avoid square roots of negative numbers. Okay, because if you do that, you won't get an answer. And the whole point is that a function pairs an x with a y, and if you plug in a number where the calculation can't proceed, then you don't get a y, and it doesn't work. So you don't believe me, so say square root of negative 4. Like, say you put a number in a function, and that was the calculation that resulted. It doesn't give you an answer, okay? And so we would like to avoid that. What's the other thing that we would avoid is taking a number and dividing by 0, okay? So those are the things that can go wrong in functions when they're given as formula. So I look at this one and say that I want to give the domain, just like up there. Could this first thing go wrong? I mean, could in any way in that function, can you end up having the square root of a negative number? There's not even a square root there, so I don't see how that could happen. It does have a division, and I suppose that we could run into this, okay? So we'll say that, all right, we want to avoid 7 minus x being equal to 0. You know, this thing that's down there under the bar that we're dividing by, we don't want that to be 0. And I just need to figure out the x that's going to make that happen. So we'll solve the equation. We could say add x to both sides, and it will say 7 is equal to x. So we want to avoid x being 7 or 7 being x. Same thing, however you want to say it. Okay? So that's our answer. We could say the domain was just that x cannot be 7. Anything but 7 is going to work there. All right? Now, sometimes just maybe you get the idea with that. Okay, and if you're happy with it, fine. But you might think of it like this. If you like to think about things in different ways, then try this. Like a function pairs an x and a y, and that's like saying you put a number in and you get something else back out. It's inputs and outputs. So just like say you put 7 in for x, what would happen if you did the math? It'd be 4 over 7 minus 7. It'd be 4 over 0. And then you get your calculator, and you say you're just trying to do the math, and you say 4 over 0. All right, and then I'll have my answer. Well, there's no answer to that. You can't. It's impossible to divide by 0. You don't get a result, and no answer. There is literally no answer that you get out the other end. That's what we want to avoid, right? So okay. You put an input, but you didn't get an output, and that's what we want to avoid. So I could say the domain was that x can't be 7, but we always write our answers in interval notation. So how am I going to express every number but 7? The way I do it is like this. Go from negative forever over to 7, but don't include the 7. Remember, the parentheses means that number is not included. Then we put this symbol, and this symbol is the union symbol, which is like saying pick back up at 7, but again, don't include it. That's a parentheses, and then go to forever. So it's like from negative forever to 7, skip over the 7, pick back up, and go to infinity. Okay? Now, you might say, well, it's so much easier to just say x not supposed to be 7. Well, that might be true, but we have our reasons for writing the domain with the interval notation. So if this just seems completely bizarre to you, it means the same thing as that, okay? You're just going to have to learn how to write it that way. Okay, now, with this one, same thing. I want you to give the domain. And which of these kind of problems could come up? Could we have a division by 0 there? No, that's not going to happen. There's no division. Could we have possibly a negative under the root? Now, that could happen because that does have a square root built into it. Okay? All right. So let's say this. Let's say, well, we don't ever want a negative under the root. So let's say like this. We need x plus 4 to be greater than or equal to 0. We need this thing that's under the root to be greater than or equal to 0. Okay. Isn't that the same thing as saying that we don't want it to be negative? We want it to be positive. That's okay. We want it to be 0. That's okay. And say you're like skeptical about the 0. Well, does the square root of 0 have an answer? Yeah. Square root of 0 is 0. Because 0 squared is 0. So it's okay to have this inside part greater than or equal to 0. Now what's that mean for the x? I'm trying to make a statement about the x would need to be this number or these numbers. So I'll solve this for x and make my statement by subtracting 4 from both sides. when we solve, we do the same thing to each side. We'll say x is greater than or equal to negative 4. And I guess you could say, and you know, for the sake of getting the point across, you could say that's the domain. The domain for that function is negative 4 and everything bigger than that. And then you could plug the numbers and you can see that they work. And then you could even try something that violated this, like say negative 5. Plug it in there. It won't work. Okay? The idea is you put a number in and you get an answer. The domain will ensure that every number you put in gives you an answer. That's the way we like things to work. Now, so that gets the point across. How do you say that with interval notation? I want negative 4 and everything bigger. I want the x to be greater than or equal to negative 4. Well, I want to include the negative 4 this time. X is greater than or equal to negative 4, so I include it. And then I go to forever. We always put a parentheses around the infinity because it's the numbers are endless. They never stop. There's no last number to include. So negative 4 to infinity. All right. So with this one sheet of paper, you've seen a little review of what a function is and what if it's given to you as a graph, what if it's given to you as an equation, and you learn how to think about it both ways. Okay? So there's one other thing I want to talk about that comes up through this topic, and it's that sometimes we combine functions, and then if we're dealing with functions anyway, we might give a statement about the domain. And you might say, you know, these questions seem very contrived and arbitrary, and the reason for that is we're just, you know, we need to learn the skills of doing math, okay? The applications will come later with whatever field that you're interested in. But I can give you like a little motivation to believe that we might add or divide functions. Like one very easy, relatable example is a profit function, okay? And if you have a business, it might be that you have a function that can calculate the revenue, which is the money that comes in. And you might have another function that calculates the cost, because like you got to spend money to make money, so there will be costs involved in doing business. And what's your profit? What do you get to keep? Well, the profit function would be the revenue function, take away the cost function. It's just by definition, that's what profit is, revenue minus cost. So if you had those two functions, you would subtract them and you could get the profit. So yes, we sometimes combine functions. All right, it happens. Okay, now for, say, here's my example. I give two functions. One's called f, the other's called g, and they're just names. You can't call them all the same name because then you can't tell them apart. So this one's called f, this one's called g. And I'd like to calculate this function f plus g and this one f over g. And to be honest, like to find that function, it's exactly the way it looks, okay? So you might think of it like this. You might say, I want to find the function f plus g of x, where, you know, this being the name of the function, and what's the x? X is always the input of the function. The name gives away how you do it. I mean, you literally, you take the f function. Okay, there it is, right, this one. And you add, just like it says, the g function. It's that simple. I mean, we do exactly what the name of the function tells us to do. Now, so I wrote down what you would do, but now it's on paper, what can you do with it? Like, can stuff be combined or canceled? And that's always the thing when we do math is if we can simplify or combine, then we do it. And I notice about this that those are two fractions and they have a common denominator and therefore they can be added. So I could say 2 plus, let's see, 3 plus 1 over common denominator x. That's going to be 4 over x. Okay. All right. So let's give our answer like this. F plus g of x is 2 plus 4 over x. And that will be its simplified form. It says to give the domain also. All right, so the domain. Look at that. What do you think that the x can be, or what do you think it can't be? Don't we want to avoid ever dividing by 0? We never do that because we never get anywhere with it and it doesn't give us an answer. So in that function, the only number that won't work is 0 for x. So we'll say, in the same fashion as has been for other problems, all numbers for x except 0. From negative infinity to 0, don't include the 0, skip over it, pick back up, go to infinity. Okay? All right. So that's how we do something like that. F over g. Now, just if f plus g means you add the functions as given, then f divided by g must mean that you divide them. Okay? So let's go through the thought process like this. To find f over g. Apparently, what that would have to mean is take the f function, the one that's given by that name. Let's see, 2 plus 3 over x. And divide by the g function. Okay, so 1 over x. All right. Did we write everything down? Is it f? Yeah, divide by g. Okay, it's there. Now, can we do anything with that? Can we simplify? Well, I have fractions here. And how do you divide fractions? Let's think about that for a second. How do you do it? And I know this looks more complicated than you'd probably like it to be, but it's sort of like, how do you divide a half by a fourth? Okay? What we have here is not actually too much different than what you're looking at this point. So, all right, well, the way you do that is you multiply by the reciprocal. Okay, so dividing by a fourth is actually multiplying by, turn that number upside down, 4 over 1, that's the reciprocal. Okay, and that would be, now multiplying fractions, we multiply straight across. 1 times 4 is 4, 2 times 1 is 2, 4 over 2 is just 2. Okay, so that's how we divide fractions. Now that's, one of many, many things that we can review. If you work the assignments and you get stuck and you realize you forget something that you think you need to know, then you just have to bring it up, all right? So anyway, okay. I would need to do that over here because this is essentially that thing up there divided by this thing down here. It's dividing fractions. Even though it might look very much different than that problem, it's the same situation. So how do we do that? Well, I said dividing fractions is multiplying by the reciprocal. So notice how I wrote that down. Does it look just like how I did over here? Yeah, I mean, maybe it looks more complicated, but I'm doing it the same way. And then, how do you take something and multiply? Like there's 2 terms there, and in parentheses, multiply by that. That means that everything in here is multiplied by that. Okay? And that's x over 1. Do you really need the 1? I wrote it just to be consistent in how I'm doing this, but it's just really an x. So wouldn't it be 2x, 2 times x, then plus, what's 3 over x times x? Well, in that case, the x's would cancel, and 1 on top, 1 on bottom, we get 3 over 1. So that's just going to be 3. Okay, so 2x plus 3. All right, now let's give our answer. Okay, f over g is 2x plus 3. And now for the domain. Now this will be a little tricky, but that's the way it is for this problem. Now you might say, oh, for 2x plus 3, everything works in that. That's true. If that's all you have, if that, is there anything else in this question besides f of x is 2x plus 3? That's all it is. Okay? And here I'm saying 2x plus 3 is the final answer, and that would be correct. But where did this come from? Like, it came from somewhere. It came from that, right? I just reduced it and simplified it, but it's really just, is this deal up here, that's just a simplified form. So when I find the domain of this function, I need to look at, well, what was it really when I started, okay? And look at that. Is there anything we want to avoid there? We never divide by 0. Here you don't want to divide by 0, and there you don't want to. What x would cause division by 0? Be if x was 0, okay? So the domain is in that, as you see, it's just that the x can't be 0. So how do we say that? Negative infinity to 0 with the parentheses. Pick up at 0. We'll continue from there to forever. All the zeros have parentheses because they're all left out. Okay? Alright, so there's how we would do the domain. Alright, so that'll take you through not every single thing that you will ever see with domain and range, but that's a lot of it. You know what to do from here. Practice the homework, ask questions, and repeat.